is Bjarne Decker and I'm responsible for the computer science laboratory. Our job, that is to put research to work. And our main challenge, that is how to program large real-time systems as efficiently as possible. And after many experiments, we decided that we had to move from conventional high-level languages such as Ada, Chill, C++, etc. into the world of declarative programming. We also found out that the only way to do that was to develop our own language, and a language which is called Erlang.
Erlang is a real-time declarative programming language. Declarative programming languages have several advantages over traditional languages. For example, programs in such languages are considerably shorter than the equivalent programs in imperative languages. Here, for example, is a program in C. And here is the equivalent program in Erlang. Up to now, declarative programming languages, such as Prolog or ML, have not been used in real-time applications, so we've had to add a notion of concurrency in real time. Erlang is a real-time declarative programming language. Erlang is a real-time declarative programming language. But in order to experiment with such languages, you need more than just a computer. You need a real-world application and real hardware to run it on. Let's go into our lab to see how we've done this. And this application is based on telephony. We have programmed an Ericsson MD110 PABX, this PABX you see here, using Erlang. But that's not really quite true, because we've changed the standard MD110 very, very slightly so that it communicates with the Sun workstation. We're running X Windows on a Sun workstation. Erlang is a real-time declarative programming language. We're running X Windows on a Sun workstation. Erlang is a real-time declarative programming language. We're running X Windows on a Sun workstation. Okay, let's just make a normal call just to see that the system works. Hello, Mike. Hello, Joe. System working? Seems to be. Okay, fine. Okay. Right, we're going to do that again. I'm going to dial Mike again. 1, 6, 7.
What we see here is a symbolic trace of the communications to and from the number analyzer. Then returned port 67, which signifies the hardware address of the telephone. Here again we see a symbolic trace of the communications to and from the number analyzer. Again, it got the request to analyze the digit 1. Return the result and get more digits.
Erlang is a real-time declarative programming language.
Finally, it got the request to analyze the digits 1, 6, 9, but this time it returned the result invalid, as this number is invalid.
Okay, we've just shown you one of the properties of the language, that is a symbolic language, and that symbolic information is always available. And now I'd like to show you another property of the language, and that is how we handle errors. And in order to show you this, that I'm first going to make a perfectly normal call, as I did before, to Joe, on this telephone. Hello, Joe.
Hello, Mike.
Hello, Joe.
Hello, Mike.